Hi everyone. Today we're going to do some work on a new topic, and the topic is straight line graphs. Hopefully this is going to take us a few lessons, so we're going to keep it reasonably easy today, and we're going to be working on things that are stuff you've done before, so everything I do today you should recognise from last year. Now I have included an attachment, and if you've got a printer then great, print it out and you can actually work on it. If you don't have a printer, it's still totally possible to do this. It might take you slightly longer, but you can do it in your exercise book and you can copy out the examples. So each section I'm going to do some explanation, and then I'm going to pause the video and I'm going to suggest how long you might want to spend on the exercise, and then you can unpause the video and watch the next bit. So in that sense it will look quite similar to a normal lesson. Okay, so let's make a start. Alright, so this first section is all to do with finding the midpoint of a little line. So what we're going to do to begin with is we're going to identify the coordinates of the endpoints. So if we have a look at this first point, point A, along the corridor to 1, upstairs to 7 is 1, 7. And then this one, along the corridor to 5, upstairs to 6 is 5, 6. So there's actually two ways of finding a midpoint. This one is nice and easy because it's already been drawn for you, and actually you can probably just work out by looking where the midpoint's going to be. So if I have a look there, I reckon the midpoint's going to be 3 and then 6.5. So I think my answer is that the midpoint of that line is at 3, 6.5. But there is a cleverer way of doing it. So method one is to look at the graph, draw it out, and put your spot on there. But if you want to try and do this without drawing the graph, then you can do it. So what I want you to do is I want you to look at the two x coordinates, which are 1 and 5. And I want you to look to see if you can work out where the 3 might have come from. And I want you to look at the two y coordinates, 7 and 6. And I want you to see if you can spot where the y coordinate of this midpoint might have come from. And hopefully you'll spot that if you take the 1 plus the 5 and then divide it by 2, that's 6 divided by 2, which is 3, and that'll give you your x coordinate. To get the y coordinate, you could have done the 7 plus the 6 divided by 2, which is 13 divided by 2, which is 6.5. So if you don't want to draw it out, then what you could do instead is you could add together the two x coordinates and halve it, which would get you the x coordinate of the midpoint, and you could add together the two y coordinates and you could halve it, and that would give you the y coordinate of the midpoint. So that is how to find the midpoint of a line segment. Don't worry about the word segment, just line segment just means a short bit of line. Okay, so what I would like to do now is pause the video and have a go at the questions in the exercise. I've given you this activity here, which you can do on there. It says here, write the coordinates of the endpoints. So that means identifying the coordinates of these endpoints, and it says also work out the coordinates of the midpoint, and you can use either of the techniques that you want. The really clever thing about this strategy here is it also works with negative numbers. So if one of these or both of these is a negative number, then just do the calculation using the correct rules and it will actually work out perfectly. Alright, so you can convince yourself that works by doing one of the exercises later on. So I suggest you only need to spend about 5 minutes on that first exercise, and we'll come back and talk about this in a moment. So pause the video and have a go at that exercise for 5 minutes, please. Okay, welcome back. Hopefully you've had a go at this exercise here, and the answers to this are at the very end. So at the very end, if you want to take a quick look, and you can mark your work. It's a bit difficult to work out what they're talking about, but these are the endpoints of each of the lines, and then these are midpoints of each of the lines. Alright, so that's there. The midpoint of CD is supposed to be 5, 1, so that should be your answer to the first one. And these are your endpoints on the first one. So C and D are your endpoints, and that is the midpoint of those two. Alright, So let's start the next section. So the next section is all to do with recognizing and naming vertical and horizontal lines. So I'm just going to pause the video and get myself a ruler. Okay, off we go. So I want to talk about the names of the lines that are horizontal and vertical. We want to be able to give them names, and the names we give them are going to involve algebra. So let's have a few examples. So the easiest one I could draw is this one here. So that is a vertical line, and it goes through 3 on the x-axis. And then we're going to give that line there a label or a name, and the label we're going to give that one is x equals 3. Now, there's 2 reasons for that. One, it goes through the x value of 3, which is the way that some people remember it. But more importantly than that, the reason that we've named that line x equals 3 is that every single point on that line has an x coordinate of 3. So every single point on that line has an x coordinate of 3. Let's have a look at that. So that's 3, 1. That's 3, 3. That's 3, 5. So every single point on that line has an x coordinate of 3. This is 3 minus 4. So that is why it is labelled as x equals 3. If we do another example of a vertical line, let's go for this one here. Let's go for that one there. That is still vertical line, and that we are going to label on as x equals minus 2. And that's because every point on that line has an x coordinate of minus 2, and because it goes through minus 2 on the x-axis. The horizontal ones are similar. So if I did this one and this one. So if we have a look at this one first, it's a horizontal line. So every single point on this has the same y coordinate. So I'm going to call that y equals 4, because every point on that line has a y coordinate of 4. Don't care about the x coordinate, but I do care that the y coordinate has to be 4. And then down here, similarly, it's also y equals, because it's a horizontal line. This one is minus 3. So there's a couple of special ones, and this is what we're going to talk about next. So let's talk about this line here. Now it's hard for you to see because I'm just drawing a line straight on top of the x-axis. So I've just drawn a line straight on top of the x-axis. So this line here is known as the x-axis, but it is also labelled using this technique here. So it is y equals 0. That's because every point on the x-axis has a y value of 0. And then similarly, this one here, we could call it the y-axis, but we could also call it the line x equals 0, because every single point on that has an x coordinate of 0. So that is how to label on horizontal and vertical lines using this type of rule. So again, you're going to stop the video for a while, and you are going to try and have a go at this exercise. So it should only take you 5 or 10 minutes. You're going to be labeling on each of these, and you're going to be drawing some for yourself. Some people find this activity a little bit odd because some people think it's the wrong way around. Some people think that the vertical ones should be y equals and the horizontal ones should be x equals. So just watch out for that. It's a little bit counterintuitive. Hopefully I've explained why the vertical ones are x equals. So these ones are x equals and these ones are y equals. So be careful. Okay. Alright, so if you pause your video now, have a go at that exercise, 5 or 10 minutes maximum, and then come back when you've had a go. Okay, welcome back. You've now got 2 exercises done, so feel free to mark those and pause the video again if you want to mark it. The answers are at the end, a bit more obvious how to mark that second exercise. This one is probably the longest part of today's lesson, we are going to remember how to draw these sorts of lines. Obviously, these are more complicated than the lines that we were drawing previously. The lines we were drawing previously was just horizontal and vertical, but now they're going to be at an angle. And hopefully you can remember this from year 8 and from year 9. And then next lesson we'll take this further and we'll start to do some new stuff. So with the method we're going to use today for drawing this line here is the method of table of values, or using a table of values. So here is my table of values. If we read the example, it says draw the graph of y equals 2x plus 2 for the values of x between -3 and +2. Now, all that means is that we're going to use a table of values, and our x value is going to start at -3 and it's going to go through to +2. So that means that when I draw it on here, I'm only going to get the answers in this region here. So it's going to look something like that. Okay. So what we're going to do is we're going to need to use this table of values. Now this tells me that to get the value of y, I need to multiply the value of x by 2 and then add 2. So this is a function. So I'm going to put a value of x in here. I'm going to substitute my value of x in here, and then it's going to tell me to multiply it by 2 and then to add on 2. Now, a couple of tips when you're using a table of values. First of all, do the positive ones first. Then do 0, and then work your way down into negatives, because these are much more difficult. Secondly, sometimes they actually give you some of these y values first. And so what I want you to do is if they give you one here, just check that you get that value yourself before you do the ones that are blank. And in this case they're all blank, but if they do give you an answer, check that you can get that answer too. So remember I said we're going to start with the positives. So if x equals 2, I'm putting x equals 2 in here. So I'm doing 2 times 2, which is 4, plus another 2, which is 6. So that needs to be 6. Now I'm going to put a 1 into here and find out what the value of y needs to be. 2 times 1 is 2, plus the 2 is 4. And now I'm going to put a 0 in. 2 times 0 is 0, plus the 2 is 2. And now I can start to put my negative numbers in. Now obviously substituting negative numbers into this is quite hard. So that's why I started off with the positives, and you can sometimes spot the pattern. And sometimes you don't even need to do these negative ones if you're confident with what the pattern looks like. But I am going to do a little bit of substitution here just to remind you. If you are struggling with a substitution, you could do a little bit of work on the side. So 2 times -1 plus 2. That's what I'm currently trying to do to work out this value here. So I've replaced x with -1, and there it is. 2 times -1 is -2. -2 plus 2 is 0. So the answer in this box is a 0. I'm going to do the next one using this strategy down here. So it's 2 multiplied by -2, add 2. Bib maths tells me I need to do this bit first. So 2 times -2 is -4. -4 add to 2 is -2. So if you are confident with your negative numbers, then you can do stuff like that. But you do need to be good at both multiplying and adding and subtracting negative numbers in order to do these substitutions. If you're not confident at doing that work with your negative numbers, then obviously you could use the rule. So the rule is 6, 4, 2, 0. You can see it's going down in 2s. So I think the next one would need to be -4. And I'm so confident with that, I'm not even going to do the substitution. So let's go ahead and plot these values on my graph. Again, starting with the positive ones and then working my way down. So 2, 6, 2, 6. 1, 4. 0, 2. Okay, each time I'm being careful, this is my x coordinate, so along the corridor, up the stairs, x, y. I've got -1 along the corridor to -1 and up and down the stairs to 0. Along the corridor to -2 and down the stairs to -2. Along the corridor to -3 and down the stairs. Now, I'm going to need my ruler and I'm going to need to join that up with a nice straight line. At this point, you will know whether you've made any mistakes in the table. because it needs to be a straight line. It says we're drawing straight line graphs. There's my straight line. If one of your values is up here, or even worse, up here, and all the others make a straight line, then you know you've made a mistake in the table, so you're going to go back up and check that one. Okay? What we're going to do next is have a look at a couple of special cases, a couple of special graphs, and they are y equals x and y equals minus x. So these are obviously a little bit simpler, and we need to learn what this looks like. And I reckon that this is easy enough that you can do it without a table of values. So you don't necessarily need to do a table of values for this. If you did do a table of values, then it would look like this. I'm only going to do positives. X is equal to y, so when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. So we've got 0, 0, 1, 1, 2, 2. You can see that when y is equal to x, we're going to have a diagonal line, starts up there and goes through 0, ends down there. So that's the line y equals x. Y equals minus x, you might remember that from last year. You don't need a table of values, but when x is 1, y is minus 1. When x is 2, y is minus 2. When x is 3, y is minus 3. So when x is 1, y is minus 1. When x is 2, you get the idea. And this is going to be a diagonal line down in this direction. So there you go, you've got two special cases that perhaps you didn't need to use a table of values for. However, if they look anything more complicated than that, then you are definitely going to need a table of values. Sometimes the table will be given to you, sometimes the grid will be given to you, sometimes you have to do that work for yourself. If when you're doing it, the crosses go off the grid, don't worry about it. Alright, if they go off the axes, just draw the bit that you can fit on the graph. Okay? What about some more difficult examples? Well, this equation up here, this gets much harder. This is a nice straightforward one. So I'll just give you a few ideas about how it could get more difficult. So something like that would be more difficult. So if you substitute a 1 into here, 5 times 1 is 5, subtract the 7 is negative 2. So you can see that because of the subtraction, we're going to need to get into negatives reasonably quickly. So that would be quite a lot more difficult. Here's another example that some people will find more difficult. Very different looking one. It says to get y, you're going to subtract the value of x from 10. So when x is 1, y is 9. When x is 2, 10 subtract 2, y would be 8. When x is 3, y would be 7. So each time you're going to subtract. Some of them might look like that. You might also get some that look like that. And that's much more difficult to substitute into. So it's still possible. When x is 1, you're going to be thinking to yourself, what does the value of y need to be to make it up to 5? So if x is 1, y would need to be 4, wouldn't it? If x is 2, y would need to be 3, etc. And you'll notice that in the exercise there are a few really, really difficult extension questions that are even more difficult than that. Another thing they could do is they could put a minus sign in front of the x, something like that. And again, you need to be really confident with your adding and subtracting and multiplying negative numbers in order to do questions like that. So if I was to put a 1 in, negative 2 times 1 is obviously negative 2, plus the 3 is positive 1. If you are not comfortable with your negative numbers, then that's going to be a really difficult one. So here's a few examples of how they could make it more difficult. I obviously haven't done the full table of values for those, but please be careful. If you're in any doubt, you could check it using your calculator. And this topic could come up on a non-calculator or on the calculator paper. So if it did come up on the calculator paper, then obviously filling in that table of values would be a little bit easier, wouldn't it? Alright, so now I've given you a relatively long exercise for you to have a go at. So here's a couple of questions. I've given you some axes. Here's another question here. We're going to do two graphs on there. The axis is on the next page. And there's an extension question. And there are some axes for that as well. So have a go at that activity. Maybe spend 20 minutes no longer, and then you can mark it yourself as well using the answers which are on the last page. Okay, that's it. I'm going to take that a little bit further next lesson, make it a little bit more difficult, but that's it for today. Okay.